Hi, this is Gabriel, and my goal today is to offer a $35 video for free for a limited time. If you like what you see and you meet someone that can get a lot of value out of this, let them know about this video. So you're going to want to remember this website, mastermathcourses.com. Remember to watch the video from beginning to end so that you're able to get all the mindsets for this particular problem from this walkthrough.
Hi, it's Gabriel, and today we're going to find where the function increases and where the function decreases. We want to find the points of inflection as well as the concavity. So we need to take the first derivative for part A. We need to use, since this is a rational equation, we need to find the quotient rule, which is the derivative of the first times the second minus the derivative of the second times the first divided by the second squared. F prime of x would equal, well, what's the derivative of the first? That's 2x times just the second, which would be x squared plus 4 minus the derivative of the second, which would be 2x times the first, which would be x squared, all divided by the second squared. So we're going to have a square right there. What we've been doing before is we set it equal to 0 and try to find the critical points. Well, this is a rational equation, so we need to set both the numerator and the denominator equal to 0. So I'm going to set 2x times x squared plus 4 minus 2x times x squared equal to 0. And I'm also going to set the denominator equal to 0. Whenever you have something that looks like this, and you have it set equal to 0, well, this x squared makes this equation a quadratic equation, right? Quadratic. And how do we solve quadratic equations? We factor. So what we need to do here is kind of put our hats on. I like to think of specific problems as kind of, if they switch up on you, just switch a hat. And we're going to go back to whenever we were learning about quadratic equations. We were learning that we needed a factor to solve for the solutions. And whenever it's quadratic, we typically have two solutions, or we could have one solution, or maybe we have 0 solutions. That's possible. But one of the first things that they taught us was how to find the GCF. The GCF. The greatest common factor. And the reason why I want to use the GCF is because we have two terms here, this being the first term, that being the second term, and they both have a common factor. They have a factor that happens both in the first term and in the second term. And that is this 2x. This factor and this factor. And that is the GCF. So we're going to take it out. 2x. We're going to have, if I take out this 2x from both of these two terms, well, then we're left with with x squared plus 4 minus x squared. And that works out great because these cancel and I'm left with 8x is equal to 0. That means that x is equal to 0. That's going to be our critical point. Let's go ahead and put it down here already in our number line. Now, what do I do with this? One of the things that we learned, this is also quadratic. And in fact, this makes it polynomial. It's a little polynomial remembers anything that is greater than is when you have a number that is an integer here, but it's not quadratic because that's actually a 4, so we can't call it quadratic typically. But one of the things that we can do is if we have a repeating factor, it's going to be the same factor, we could ignore that too and just try to figure out if x squared plus 4 is equal to 0. Because what this means is that there's going to be two of these factors. If I write these out, let's say this would just be redundant. That's what I'm trying to figure out over here, so why write it out twice? So let's just figure out the critical points for this part. So what I would do here is I would first subtract both sides by -4. And I would get -4 is equal to x squared. Well, when we want to use the square root property here, when I take the square root of both sides and there's a negative on this side, I get an imaginary number. If I get an imaginary number here, what that lets me know is that we won't have any critical points for this right here. So we won't have no critical points when we have an I. So if you're taking the square root of a negative number, your job is a lot easier and you can say yes. It's a little bit simpler. So we only have one critical point, 0. Let's find our test points. If our critical point is 0, then let's just have a test point -1 and 1. Those would be the easiest, right? So where do we plug it in? Where do we plug these test points in? Well, we plug them into our first derivative, which was that. Well, as it turns out, let's go ahead and write it. F prime of some number is equal to, we took out the 2x from the top, and that left us with x squared plus 4 minus x squared divided by x squared plus 4 squared. But we said that these canceled, and we really just had 4 times 2x is 8x divided by that. Squared plus 4, and all of that is squared. So that's where I'm going to plug in my test points. -1 and -1. We're also going to do something different here, and that is, since we're only trying to find whether the inflection point is positive or negative, we're only interested in seeing this sign. So 8 times -1 is a negative number. And if I divide that by, this is going to be +1 plus 4, that's 5. If I square that, that's 25. It's positive. I know that one of the properties of division is that if I divide by a negative, I get a negative. So I know I'm decreasing on this side. So notice that I didn't really have to evaluate this all the way to figure out whether I was decreasing or increasing. So that's kind of like a little shortcut that you can use when a function starts to get pretty complicated. Now let's try our next test point, which is a +1. So instead of having a -1, we're going to have a +1. What is that going to change? Well, this is now going to be positive. The numerator is now going to be positive, and the denominator is still going to be positive. Well, with division, a positive divided by a positive is a positive. That indicates that we're increasing from here to here. So now we can label our points. We can say that f of x is increasing from 0 to infinity, and f of x is decreasing from negative infinity to 0. And we're done with part A. Now we need to take the second derivative. Each problem presents different obstacles, and what I'm able to do with these walkthroughs is offer many similar problems to resolve wherever you're stuck. If you're done watching this video, it's safe to assume that you found this video valuable. So refer us to your friends. And of course, we're always trying to improve, so let us know how we can do that in the comment section below.